Hi guys, I'm back with another topic here. In this video, we will be discussing the submission part. Like when we submit our predictions to Kaggle, what is the score exactly, and where are we at the leaderboard? So as usual, here since the data is already featureized and the models are trained, we can submit our predictions by predicting the test data and obtaining the predictions as well, right? So as usual, we'll import the packages. Since we are not training anything. Uh, we are not importing any of the functions from scikit-learn except for standard scalar. Okay. So in this case, we will be reading our data along with our training data. So we will be reading train data and test data. This is our test data actually, which is featureized, and this is our training data. And here, since the test data has ID column, while doing predictions, it may not add value. So we'll just remove it temporarily from the data set, data frame basically. Now what we do is we have to pre-process the data. For that purpose, we need to pre-process from the training part and transforming it actually on the test data. So we learn from the train and we transform it on the test data. That's how it is done here. And that's why we need train data here to actually learn the pre-processing attributes. As usual, I'm creating the labels, basically the label names. And here I have a function to predict the data set. So this function is make predictions. X is our input features. Model name is one of the parameters, which is actually none here. And the labels, which is the default value, is this. Model path is one of the variables here, which actually helpful to load the models. Now, if the model name is logistic regression, we must load the logistic regression pickle file. So that's how we are giving conditions here. And if the value is none, if the value is none of this, none of this like logistic or decision or random forest, then we have to load the best model, right? That is XGBoost. For each model, we have to make submission file. So this is one of the file, one variable here, threads file, which has been saved in the models path. Model name and submission, not the models path basically. And here we are getting the predictions path. Now this code is the important aspect in this whole function. What I'm doing is giving a condition. If the prediction file exists, then just read the data as usual. Otherwise, load the model, get the predictions, and then save it in a submission file. That's what I'm doing here. Okay. We have seen this technique in the previous videos as well to avoid the repetition. So the same concept is being implemented here as well. Now, once the function is done, we must call with the various model names, right? So for logistic regression, the model name is this, and the function remains same. So lr_preds equals make predictions, x equals data, model name equals model name. Now, once we execute this, we are just printing this part, and we can see the predictions here, the probability values, and this is the ID. So once we get this, we can actually submit our predictions to Kaggle via command line command, Linux command basically. And yeah, this is the code to submit our predictions. The fun part here is getting the score. So for logistic regression submissions, we get a score of 2.50125. And the same concepts, if we apply to decision tree with the model names are different, we get to see the score, which is 2.38, lesser than logistic regression. And similarly, we can check for random forest, same function, just the model name change, and we see it is 2.41, slightly higher than decision tree score. Similarly, for XGBoost, if we do the same process, we get 2.24, which is the lowest score of all. And we can take the XGBoost model as a final model, and this is the score that we get. This is a summary of all the submissions, and the first one that is chosen is the XGBoost submission, which has the less score. So luckily and fortunately, by these techniques of feature engineering and pre-processing and the model techniques, I have reached top 5% of the Kaggle leaderboard, and this is quite good. But still, we can check for other approaches and improve our modeling techniques. See, the last point here is I got 103 position out of 2332 teams, and it's approximately top 5% of Kagglers who solve this problem. That's it for this video. In the next video, we'll discuss final pipeline where we can predict for a single point. Okay.